Hi, in this video we'll be talking about recursive functions. Recursive functions are functions that call themselves. A typical example shown when recursion is discussed is the function that returns the factorial of a number. Well, let's briefly talk about factorials in case you don't remember well what they are. To calculate the factorial of a number, you have to multiply the number by all the integers less than the number down to 1. So 5 factorial equals 5 times 4 times 3 times 2 times 1, and this equals 120. Or more generally, n factorial equals n times n minus 1 times n minus 2 times n minus 3 times, and so on, down to times 1. Now back to our first example. If 5 factorial equals 5 times 4 times 3 times 2 times 1, and 4 factorial equals 4 times 3 times 2 times 1, then 5 factorial equals 5 times 4 factorial. And more generally, n factorial equals n times n minus 1 factorial. So as you can see, in order to calculate the factorial of 5, we multiply 5 by the factorial of 4. But to calculate the factorial of 4, we multiply 4 by the factorial of 3, and so on. So if we define a function that calculates the factorial of the number n, we have to use the same function in its body to calculate the factorial of the number 1 less than n. Now we're almost ready to write our function code. There is one thing we must mention before we do. A recursive function calls itself repeatedly, but how long should it go on like that? When is it supposed to stop? This must be specified in the function definition. When we define a recursive function, we have to specify two cases in its body: the recursive case and the base case. The recursive case is the condition for which the function should call itself. The base case is the condition for which the function should stop calling itself. Let's illustrate it on our example. The function should call itself as long as the integer is greater than 1. When it's equal to 1, it should stop calling itself. So our base case is n equals 1. Our recursive case is n is not equal to 1. So here's our code, the function definition and call. Factorial. Here we have the base case, n equals 1. Here we have the recursive case. Else means n not equal to 1. And here, in this block of code, we have n times factorial of n minus 1. So here, the function is called recursively with a different argument. Now, here, we are calling this function with the argument of 5. And if we now run this code, the output is 120. So it works. What's going on when we call a recursive function like this? Well, each recursive call adds a frame stack with its execution context to the call stack. When the base case is reached, the stack begins to unwind as each call returns its result. Now we could write this function also without recursion. So let's comment it out so that we can compare the two versions. And here is the version without recursion. Factorial of n, result equals n. And here we have a while loop. While n is greater than 1, result equals result times n less 1. And finally, n is decremented by 1, and the result is returned. Let's run this code now. 120. So as you can see, the result will be the same as when we use the recursive version. By the way, there is a factorial function in the math module, so you don't have to define it yourself. Another typical situation when recursion comes in handy is handling arbitrarily nested structures. For example, the folder system. We can have folders inside other folders, and there may be yet other folders inside these folders, and so on. The structure of folders may be of arbitrary complexity. Let's represent our folder system as a list, like so. The outer list is the root folder. The nested lists are subfolders. Now we want to create a function that takes a list of folders and does two things. One, it changes the name of each folder replacing F with folder. And two, it prints the structure of the folders in a neat tree form. Now, if an element of the list is a nested list, the function should be called recursively for that list. And now here is our function. This is how we can do it. Print folders, and here's the first case, if the folder is not a list, like here. So if not is instance folder list, which means if the folder is not a list, then do the following. Folder equals folder replace F folder, so the F here will be replaced by folder, and then print the following string. This is just a visual representation of the hierarchy. Pipe, now level times 4 dashes, and folder. Else, if we have a nested list like here, so now this is our folder, and here this is our folder. So in this case, call the print folders function recursively and pass folder, so the sublist, as the first argument, and level plus 1 as the second argument. Well, level plus 1 means we will have one more level of indentation from the left in the tree representation of the hierarchy. Now let's call this function print folders, and let's pass our folders list as the first argument and the level 0. Fine. And now let's run this program. And this is what we get, a tree representation of our hierarchy. In the examples above, we had direct recursion, so the function called itself. But there can also be indirect recursion, where function A calls function B that calls function A again. Here's an example. Here we have function A, here we have function B. Now, function A prints x, which is passed as an argument to the function. And now, if x equals 1, it returns x. Otherwise, it calls the B function and returns the result of the B function. Now here we have the B function. The B function calls the A function with a different argument and returns the result returned from the A function with this argument. So let's call the A function with the argument of 5. And let's run this program. 5, 4, 3, 2, 1. Okay. So we passed 5 here. So it printed 5. Then it compared 5 to 1. Well, 5 is not equal to 1, so this was skipped. And here, B with 5 was called. So B of 5 returns A of 4. 5 minus 1. So A of 4 prints 4. And here returns B of 4. B of 4 returns A of 3. So 3 is printed, and so on. This is how it works. Recursion has its advantages and disadvantages. On one hand, it breaks a complex task down into simpler tasks and makes the code clean. on the other hand, is expensive, which means it takes up a lot of memory and time, so you should use recursion reasonably. Okay, that's it for this video. If you like it, a thumbs up would be great. Also, make sure to subscribe for future videos. If you want to leave a comment or ask a question, you're welcome to do so. Thanks for watching.